You ever wonder how life-saving vaccines can travel all the way across the world without spoiling? Or get this, how astronauts get to eat shrimp cocktail up in space? Well, the answer lies in this remarkable piece of tech you've probably never seen, but you've almost definitely benefited from, the Lyophilizer. You might know it by its more common name, the freeze dryer. So here is how we're going to break this down. First, we'll tackle the basic preservation puzzle. Then we'll dive into the wild science of drying something without ever melting it. After that, we'll take a look inside a freeze dryer to see how it works. Explore where you see this tech every day. Yep, from vaccines to coffee. And finally, we'll take a little peek into the future of preservation.
All right, so here's the fundamental problem we're trying to solve. Just think about really delicate things like life-saving medicines or even nutrient-packed foods. They're incredibly fragile. And the number one enemy of preservation? It's water. Water lets microbes grow and everything spoils. The obvious solution, right, is just to dry them out. But if you use heat, you just cook away the very things you're trying to save. So the real question is, how do you get rid of the water without totally destroying the product? Let's make this really concrete. Imagine you have a delicate vaccine, and you need to get it to a remote village that doesn't have a reliable cold chain. You know, that constant, unbroken line of refrigeration. Heat will absolutely wreck it. But what if you could remove the water so completely that the vaccine becomes perfectly stable, just sitting at room temperature? Now, that's the puzzle we need to solve. And the solution is frankly ingenious. It's called lyophilization. That's really just a fancy way of saying freeze drying. Instead of boiling water away with heat, you first freeze the product totally solid. Then, under a really strong vacuum, you gently encourage that ice to turn directly into a vapor, completely skipping the liquid phase. And because it never melts, the delicate structure of the material is left perfectly, beautifully intact. So that direct jump from a solid ice straight to a gas, it actually has a name, sublimation. And that is the scientific magic at the very heart of freeze drying. By sidestepping the liquid water stage entirely, you prevent the kind of damage that would normally just obliterate the delicate architecture of cells and proteins. And the cool thing is, you've actually seen this happen out in the real world. Just picture a patch of ice on the sidewalk on a really cold but sunny and dry winter day. You notice that over time, the ice just vanishes. It never melts into a puddle, it just disappears. That's sublimation in action. A lyophilizer basically just takes that natural process and puts it inside a very, very controlled box. The whole process really happens in 3 key stages. First, everything is frozen solid. Simple enough. Then comes what's called primary drying. This is the main event. You've got low pressure and a little gentle heat, which causes about 95% of that ice to sublimate away into vapor. And finally, you have secondary drying, which is kind of like a finishing polish. You use slightly warmer temperatures to chase off those last, most stubborn water molecules that are chemically stuck to the material. Okay, so we've covered the theory, but how does the machine actually pull it off? Let's take a look inside the box and see exactly how Lyophilizer executes this elegant 3-stage dance. It's a really fascinating piece of engineering. So, the operational sequence is incredibly precise. First up, you load the product. Then it gets frozen solid. We're talking way down to -40 or even -80 degrees Celsius. Next, a powerful vacuum pump kicks in and sucks almost all the air out of the chamber. With that low pressure set, a little bit of heat is gently applied to start the primary drying. That's the sublimation part. Now, all that water vapor that's coming off the product, it's immediately trapped on these super cold condenser coils, turning right back into ice so it can't cause any trouble. Then comes the secondary drying to finish the job, before the final product is sealed up, perfectly preserved. Let's quickly break down the key players inside this machine. You've got the vacuum chamber. That's the main stage where all the action happens. The vacuum pump is the workhorse that creates that critical low-pressure environment. The heating shelves provide just enough gentle energy to get the sublimation going, while the super cold condenser acts like a vapor trap, grabbing all that water and freezing it solid. And tying it all together is the control system, the brain of the operation, making sure every single step happens at the exact right time and temperature. So we have this incredible technology, but where do we actually see it in action? Well, the applications are way more widespread and important than you might think. They range from literally saving lives to, well, making your morning cup of coffee. In the world of pharmaceuticals, this technology is a complete game changer. It allows us to stabilize all these complex biological drugs, things like vaccines, antibodies, and enzymes, that would normally spoil in just a few days. By freeze-drying them, they can become stable on a shelf for months or even years, with no refrigeration needed at all. This is exactly how we get life-saving medicines to every single corner of the globe.
But it's also probably in your kitchen cabinet right now. You know that instant coffee that dissolves so perfectly in hot water? That's lyophilized. Those crunchy little strawberries in your breakfast cereal? Yep, same thing. It's just the absolute best way to remove water while keeping all the flavor, color, and nutrition, which also makes it perfect for creating lightweight food for hikers and, of course, astronauts.
And in the lab, it's a total unsung hero. Scientists use it to preserve pretty much everything, from microbial cultures to the delicate reagents used in diagnostic kits. It allows for the long-term storage of all kinds of sensitive biological samples without needing these massive, energy-guzzling, ultra-low temperature freezers. So the benefits are huge, right? You get a product with its original structure perfectly intact, it's incredibly stable, and it rehydrates almost instantly. But there's always a trade-off. These machines are really expensive to buy, they use a ton of energy to run, and the process itself is painfully slow. So, given those challenges, the cost, the energy, the time, where does this technology go from here? Well, the future is all about innovation. It's about making freeze-drying smarter, faster, and a whole lot more efficient. And we're already seeing some major advances. Automated controls are making the process way more consistent. IoT integration means a scientist can literally monitor a cycle from their phone. We're seeing new energy recovery systems that are helping to slash those massive electricity bills. And smaller, modular designs are finally putting this powerful technology within reach of smaller labs and companies.
And to really get why all those innovations matter so much, just consider this. A single freeze-drying cycle often takes anywhere from 24 to 48 hours. I mean, that's 1 to 2 full days. In a manufacturing environment, that is a massive bottleneck. So every single hour that's saved through better technology translates directly into lower costs and getting more product out the door. At the end of the day, lyophilization is one of those quiet, cornerstone technologies, working in the background to preserve the things that matter most to us, from our medicine to our food. And as it gets smarter and faster, it opens up a really fascinating question. What's next? From complex living tissues for transplants to entirely new kinds of food, what other fragile, precious materials will this incredible process allow us to save?